Parallel lines and transversals. So a transversal is a line that intersects through two or more coplanar lines at two different points. So if we zoom in and we look at this model, this line here is called the transversal. This transversal intersects two different lines at two different points. Identifying a transversal is very important for future problems. You have to be able to identify which one is the transversal, which one are the coplanar lines, or which ones are the coplanar lines. Besides from the transversal, a couple other key parts to look at on this graph is going to be your points that lie outside of the coplanar lines. These are called, or in these regions, you would have your exterior points. In between the two lines, so in the middle of the two lines, any points that lie in this region are going to be called your interior points. Also, any angles that lie in the blue shaded region are called exterior angles, and any angles that lie in the orange region are going to be called interior angles. So between the lines versus outside of the lines. The first angle pair we're looking at on our model is going to be called corresponding angles. And corresponding angles are two angles in the same position with respect to the transversal, but on a different line. Looking at the model above, looking at this model here, corresponding angles are angles that fall in the same position with respect to the transversal, but on a different line. So for example, angle 1 is above line Q and to the left of line T. Angle 5 is in the same location, and when I say the same location, it is above line R and to the left of line T. That's how you know they are in the same location. So in the diagram, we could say angle 1 and angle 5. And I can put the diagram right in here so we can look at it a little more closely. So 1 and 5. If I was to identify more, we could say 2 and 6 are also corresponding angles. We could say 3 and 7. We could say 4 and 8. And those are all of your corresponding angles. Next, we're going to be looking at alternate interior angles. Alternate interior angles are two angles on the interior, but on opposite sides of the transversal. If we look at our diagram above, angles that are on the interior, so recall that interior angles or interior points are highlighted in orange, but on opposite sides of the transversal. Here's your transversal. So angles on opposite sides would be angle angle 4 and angle 6. Those are alternate interior angles. And there's only one other pair. It would be angle 3 and angle 5. So interior angles opposite side of the transversal. Next, we're looking at alternate exterior angles, and these are two angles on the exterior but on opposite sides of the transversal. So based on our diagram, our exterior angles are highlighted in blue, and we're looking for angles on opposite sides of the transversal, but in the blue exterior shaded region. 1 and 7 would be alternate exterior angles, and also 2 and 8. We have same side interior angles that are two angles on the interior of two lines and on the same side of the transversal. Interior angles fall in the orange region. They are on the same side of the transversal to be same side interior. My first example is angle 4 and angle 5. The second example would be angle 3 and angle 6. And the last angle pair we're going to look at is called same side exterior angles. And these are two angles on the exterior of two lines, but on the same side of the transversal. So as you can tell, all of these angle pairs are determined by where the transversal is, which is why it's so important that you can identify the transversal. Looking at our diagram, blue angles are going to be exterior angles. So angle 1 and angle 8 are on the same side of the transversal. And the only other pair is 2 and 7. So now that we've gone through all of the angle relationships as far as parallel lines, or as far as coplanar lines, I should clarify that, coplanar lines go, we can take a look at identifying different pairs. So looking at a diagram and picking from one of these 5 angle relationships as to what the angles are. For the first set of examples, we're going to refer to this figure and we're going to classify each one of these angle relationships. So each one of these over here. I'm going to highlight them as I go. Number 1, angle 1 and angle 5. So before I identify that, I'm going to quickly note that here's my two coplanar lines. And I know that because there's only one intersection point within another line. But here is my transversal. I know this is my transversal because it has to intersect at least 2 lines, and it does. It intersects both of the lines I traced over in orange, so I know that's my transversal. So this cannot be a transversal because it only intersects one line. This cannot be a transversal because it only intersects one line. This can be the transversal because it intersects two lines. So now that we identified the transversal, I'm going to do the same thing really quick, and I'm going to highlight my exterior angles in blue, and I'm going to highlight my interior angles in orange. Give me 1 second on that. And everyone should be able to easily see what's exterior and what's interior. It is definitely helpful if you shade, but as far as identifying them, you should be able to. So for number 1, we're looking at angle 1 and angle 5. So those two angles are on opposite sides of the transversal. The transversal is highlighted in purple, and they are in the exterior region. So those are going to be exterior angles, specifically alternate exterior angles. And I'm just going to abbreviate to save us some time on the recording. So alternate exterior angles for number 1. Number 2 is angle 6 and angle 7. Angle 6 and 7 both fall on the interior region, and they are on the same side of the transversal, so that makes them same side interior. Angle 2 and angle 4. So those are both below the lines I have highlighted in orange, and they are both to the right side of the transversal. That means they have to be corresponding angles because they are in the same location with respect to the transversal. Next, we have angle 2 and angle 6. Angle 2 and angle 6 both fall within the shaded region, shaded orange region, which means they are interior angles, and they are on opposite sides of the transversal. So we're going to say that they are alternate interior angles. Angle number 5, angle 3 and angle 7, those are also alternate interior angles. Angle 5 and angle 7, those are in the same location with respect to the transversal, both to the left side of the transversal, both below the orange lines. Those are called corresponding angles. Angle 4 and angle 8, both in the shaded blue region, which means they're exterior. They are on opposite sides of the transversal, so those would be considered alternate exterior angles. And lastly, we have angle 2 and angle 3. Angle 2 and angle 3 are on the same side of the transversal. They are also both within the orange shaded region, so those would be same side interior angles. Quick reminder from the last lesson, or one of the last lessons. We have to know that vertical angles are a pair of non-adjacent angles formed by the intersection of two straight lines. We need to specifically know that the vertical angles theorem states that vertical angles are always congruent. If I draw a model, vertical angles are formed by what appears to be an X. These two angles are congruent, or else we could say they are equal. We also learned about linear pairs. So linear pairs are angles that are adjacent and are formed by two intersecting lines. Linear pair theorem states that if two angles form a linear pair, then they are supplementary, meaning they sum to 180. So linear pair has to be adjacent, meaning they have to be two angles that share the same vertex, and they have to sum to 180. So in this example, angle 1 and angle 2 are considered a linear pair because they sum to 180 degrees and they share a common vertex. Now that we've talked about angle pairs, we need to talk about angle pairs specifically using parallel lines. So parallel lines are coplanar lines that do not intersect. Parallel lines are always the same distance apart and they never meet, meaning this distance right here remains the same throughout. It never changes. Those two lines will never meet. They are two distinct lines that are both perpendicular to a third line. I wrote this note before just to save myself a little time, but when we look at this, notice these arrow symbols. These arrow symbols indicate that the lines are parallel, so you match them. We have an arrow symbol here, we have an arrow symbol here. That indicates that these two lines are parallel to one another. So if you see a model that does not tell you the lines are parallel, but you see those two little arrows, then you instantly know they are. Also, you've probably seen it before, but if you forgot what the parallel symbol is, if we were to identify these two lines as parallel, so if we identify this line and this line as parallel, and we need to write a statement, we could say that line JK, obviously use the correct form, is parallel. It's two bars. Literally looks like two parallel lines. So line JK is parallel to line LM. And it's equally as important that you know how to write that. So make sure you know how to use the parallel symbol. Looks like two parallel lines, shouldn't be a big deal. Within parallel lines, there are a few postulates and theorems. These postulates and theorems only work on parallel lines. They do not work on lines that are not parallel. So the first postulate is the corresponding angles postulate. And this says that if a transversal intersects two parallel lines, the pairs of corresponding angles are congruent. If we look at the model, this is your transversal. We know that because it intersects two separate lines. If we have corresponding angles, such as angle 1 and angle 3, then those angles are congruent. I can say angle 1 is congruent to angle 3, and if I was asked to reason why or provide a reason why, I would say because of the corresponding angles postulate. Next, we have the alternate interior angles theorem. The alternate interior angles theorem states that if a transversal intersects two parallel lines, then the alternate interior angles are also congruent. Here's our transversal, intersecting two separate lines. Alternate interior angles could be angle 1 and angle 3, or we could say angle 2 and angle 4. But angle 1 and angle 3 are alternate interior angles, so we automatically know that they are congruent. If your directions said to provide reasoning, you would say because of the alternate interior angles theorem. On this one, let's list one more. Let's also list angle 2 and angle 4. Using the appropriate amount of angle arcs. And I can state angle 2 is congruent to angle 4. The last theorem is slightly different, and this is called the same side interior angles theorem. This states that if a transversal intersects two parallel lines, then the interior angles on the same side of the transversal are supplementary. So a little bit different. And supplementary states that two angles sum to 180 degrees. Looking at our diagram, angle 1 and angle 2 are same side interior angles. So for this one, you could say that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. They are called same side interior angles. This obviously requires a little bit more work because you will be adding two angles together and setting them equal to 180. Not quite as basic as the previous two theorems, but it does come in very helpful when finding missing angle measures. Also, remember, if you're setting something equal, you always use the little m to indicate that it's the measure you're looking for. So an equal sign requires the use of the measure symbol. Okay, let's jump right into the examples. This example here is a rather complex diagram. I gave this to you because you will see them. I wanted to make sure we at least went over one of them on the note sheet. When I'm looking at my parallel markers, I see that both line A and B have a single marker. So these two lines are parallel. I'm going to highlight them in purple. I also see that line L and M have two of the little arrows on each line. That indicates that line L is parallel to line M. You match the number of connectors, or match the number of arrows. So for this, there's 6 problems here. It's going to take a little while to go through them. So I'm going to do the odd numbers only, and then you guys can complete the even numbers on your own, just to save us a little bit of time here. I will provide you with the answer, but I want you to actually solve it and figure out how you solved it by yourself. So angle 1, or number 1, is looking for the measure of angle 1. I made a note. It says you must alternate between parallel lines and transversals. So for each one of these problems, and we're starting with angle 1, we have to pick one set of parallel lines and one transversal. So what I'm going to do is I'm going to use A and B as my parallel lines, and I'm going to use L as my transversal. I just unhighlighted M, so let's forget that M even exists. So we are literally dealing with only what I have highlighted on my screen right now. So right here, we see angle 1. We see that angle 1 is right next to 75 degrees. Using what we learned in the previous class, angle 1 and 75 degrees, right here, form a linear pair. So a linear pair is going to allow us to solve for the measure of angle 1. We know that the measure of angle 1 plus 75 degrees is equal to 180. And I am asked to justify, so right under this or next to it, I'm just going to say linear pair theorem. I need to solve for the measure of angle 1, so I'm going to subtract 75 from both sides. And this is going to indicate that the measure of angle 1 is equal to 180. It is 180 degrees. I want you to complete number 2 on your own. I will quickly tell you, if you want to jot this down, that the correct answer is 75. You can answer that and fill that in at a later time. Now let's look at the measure of angle 3. So the measure of angle 3 is located here. And it appears to me that 3 and 75 are what we call alternate interior angles. If I scroll up to my potential theorems, we have these 3 to choose from, and then we have vertical angles and linear pair. So if I scroll all the way out, we have all of these to choose from. Alternate interior angles does have a theorem. It's right here. It tells you that alternate interior angles are congruent. And that's what I'm going to use to solve for the measure of angle 3. I know that the measure of angle 3 is equal to 75 degrees, and I'll just make my note right below it, alternate interior angles theorem. Next, we're looking at the measure of angle 4. I'm just going to tell you that the measure of angle 4 is also 75 degrees. And now I'm on to number 5, which is the measure of angle 5. So here we're going to have to switch things up. 5 is over here. 5 does not fall between the transversal I have highlighted in orange and the 2 parallel lines I have highlighted in purple. So that's a problem because it's not on our current diagram. We basically forgot that line M even exists. So now what I have to do is I need to switch. I need to switch what I'm using as my parallel lines and what I'm using as my transversal. I'm going to re-highlight line M in orange. And I'm going to erase line B. So now I am specifically using this portion of my diagram. For the time being, I'm going to completely forget that line B exists. So now, using line A as our transversal, intersecting at 2 locations, I know that angle 5 and angle 1, which we already solved for in number 1, are corresponding angles. So the measure of angle 5 is equal to the measure of angle 1, and we know that because of corresponding angles. It's specifically the corresponding angles postulate. All right, corresponding angles postulate tells us that. We know that the measure of angle 1, back up to the measure of angle 1. I wrote that it was 180. It is not, it is 105. So correct that if you, I think I said it correct. I think I just wrote it wrong. Correct that on your note sheet if you did the same thing as me. Anyways, we know that the measure of angle 1 is 105. So therefore, we know that the measure of angle 5 is also equal to 105 degrees. So take into consideration this note that says you must alternate between parallel lines and transversals. And using highlighters is so effective because you can clearly see what you're using for parallel lines and what you're using for the transversal. Just to complete your notes, if you're working in number 6 by yourself, the measure of angle 6 is also 75 degrees. So measure of angle number 2, number 4, and number 6 are all 75 degrees. And the last example set. I'm going to do number 1, and I'm going to ask that you complete number 2 by yourself. This is the same thing as what we were just doing, but now we're working with some expressions. So now we're solving for some variables, just throwing a little bit of algebra into this. Number 1 says that the measure of angle 4 is equal to 2x minus 17. It also says that the measure of angle 1 is equal to 85. We need to determine the value of x. So I'm going to work through this and I'm going to look to myself and I'm going to say, all right, well, 1 and 8 are both going, oops, sorry about that. 1 and 8 are a linear pair. So I know that the measure of angle 1 plus the measure of angle 8 is going to be equal to 180 degrees. And that's a linear pair theorem. I know that the measure of angle 1 is specifically 85. 85 plus the measure of angle 8 is equal to 180. Subtract 85 from both sides, and the measure of angle 8 is equal to 95 degrees. Once I know the measure of angle 8, I also know that angle 8 and angle 4 are called alternate interior angles. And alternate interior angles, by the theorem, are equal. Now I know that the measure of angle 8 is equal to the measure of angle 4. The measure of angle 8 is equal to 95, and the measure of angle 4 is 2x minus 17. When we add 17 to both sides, we know that 112 is equal to 2x. Divide both sides by x, divide both sides by 2, and x is equal to 56. Okay, we solve for that second part by what we call the alternate interior angles theorem. And the directions did specifically ask us to solve for x, so that is my final answer. I want everyone to do number 2 by yourself. I'll give you a hint. Number 2 uses the alternate interior angles theorem. Also, before we end this note sheet, I want to make a quick list of the theorems and postulates used with parallel lines. When we started this note sheet, if we go right back up to the top, we went through all these different angle pairs. There's 5 of them. There's 5 angle pairs, but there are not theorems that go with each one of them. So you have to understand what angle pairs are. That's just identifying angles. And then you have to understand what theorems are, and theorems identify angle measures, so they help you solve for an angle. So when dealing with parallel lines, specifically parallel lines, you have a few theorems to use. You have the linear pair theorem. Linear pair theorem says angles that are adjacent or next to each other, they sum to 180. You have the vertical angles theorem. Vertical angles are congruent. We have the corresponding angles postulate. Corresponding angles postulate says that corresponding angles are congruent. We have the alternate interior angles theorem. This theorem says that alternate interior angles are congruent. And the last possibility for solving, so these are your options for solving. The last postulate or theorem is called the same side interior angles theorem. And the same side interior angles theorem tells you that the two angles sum to 180 degrees. And these are your only possibilities when solving for parallel lines. Now, naming is a different situation, like I mentioned, but solving, you have 5 options to help you out with. That's it for the notes today. Please let me know if you have any questions.